Hello everybody, it's Amell, and today I'm going to teach you how to solve this problem recursively. Merge two sorted lists. In the last video I showed you an iterative solution, but this time we're going to use recursion. So merge two sorted linked lists and return it as a new list. The new list should be made by splicing together the nodes of the first two lists. So as you can see, the key here is that the two lists are sorted in ascending order, and this is the merge. This is the output. So how can we do this recursively? Well, we need to define the base cases, and we also need to compare the node in L1 with the node in L2, and then recursively move forward in the list and fix the links accordingly. So without further ado, I'm going to show you how to write the code. First, I'm going to say, okay, I need my base cases. So first base case, if L1 equals null. If the first list is empty, I just return the second list, L2. For instance, if the first list is shorter than the second list, I just return the remaining nodes in the second list. By the same token, if L2 equals null, if the second list is empty, then I just return the first list. Then I need to compare the corresponding nodes, the corresponding node in L1 with the corresponding node in L2, and choose the smaller one. So if L1.value is less than L2.value, so in this case I want to choose L1 because I want to put a smaller value first. So L1.next is a value of merge two lists L1.next L2, and then I just return L1. So what I'm doing here is that I realize that this value in the first list, the corresponding value in the first list, is smaller than the one in the second list. So I just fix the link by connecting to the result of calling this method recursively. So I have to move to the next one in L1 because I already have chosen this one, and I just fix the link by connecting to the result, and then I just return L1. Then if this is not the case, then that means that L2 is the smaller one, or maybe they have the same value. In that case, I do the same for L2. L2.next gets a value of merge two lists. L1 stays the same because I didn't choose it, but L2, I have to move to the next one in L2, so I say L2.next, and then I just return L2. So as you can see, we are choosing this. We are checking which one is smaller, and we are choosing that one to be the first node, and we connect it to the remaining nodes after the method handles all the processing, and then we return that node that has been fixed, and we choose the smaller one. In this case, L1 was smaller, so we chose L1 to be the first node in the list as we are building the list. In this case, if we got down here, if we were able to get down here, that means that maybe L2 was smaller or the same value. In that case, I choose L2 to be the first one and fix the link to be connected to the remaining, and I have to move the pointer L2 forward because I already chose this one to be the smaller one, and then I return the head, which is L2. I will run the code. Alright, I will submit the solution. This is working perfectly. So the time complexity is big O of n, where n is the length of the longer list, and the space complexity is also big O of n because that's the maximum depth of the function called stack. If you like this video, please press the like button. Don't forget to subscribe, and see you next time.